In the previous video, we talked about separation of variables and what exactly they were. And then this video, we're going to do a couple of examples. So using the separation of variables. So basically, if you remember, separation of variables basically means that you want to put all the x's on one side and all the y's on the other side. So basically, if you have a dy, you want to have all of the functions that have y's in that side. And if you have x's, then you want to have all the functions that are x's on the other side. And if it's not possible to do that, then it isn't separable. It is not, you are not able to do that problem. So let's just do an example. Okay, so what we want to do is we want to solve the differential equation. Okay, and here is what we have. We have dy over dx is equal to x squared over y squared. Okay, so the whole point of this is that I know what the derivative is, but now what I want to figure out, I want to know what exactly is the original function. Okay, so using separation of variables, one of the things that you can do, you can try to cross multiply. So I can just do something that looks like this. So I have y squared dy equals x squared dx. And as you can see, you have all of the y's and all of the x's isolated. Okay, now the next thing that you want to be able to do, now we want to go ahead and take the integral. So I'm going to integrate both sides. Okay, so the integral of y squared is just going to be y cubed over 3. And the integral of x squared is just going to be x cubed over 3. And now I'm going to write plus c. Now, why did I not write plus c over here? Well, if it was a constant and I move the constant over, you're just going to get another constant. So I'm just going to write plus c to be the combination of both constants. Okay, and now all we have to do is just solve for y. Okay, so let me multiply by 3 to all of the sides. So I'm going to multiply 3 here. And then this whole thing is going to be multiplied by 3. The 3's are going to cancel out. So I have y cubed is equal to x cubed, because this 3 is going to cancel out with that 3, plus another c, because 3 times c is going to just give us another c. Okay. And now finally, what we want to do is get rid of that 3 of the power. So what I'm going to do is I'm going to cube root both sides. Okay. So I'm going to have y is equal to the cubed root of x cubed plus c. Okay, and that is going to be my solution. To check my work, just take the derivative of this and then plug it back in here, and you should be able to get x squared over y squared. Now, here the question is, what about this c? Okay, well, c, we can't quite figure it out because we need to have some additional information about the problem. So in particular, what exactly is this differential equation modeling? So those are what we call initial value problems. So if you have an initial value problem, or so for example, if this was like modeling temperature with time, then we needed to figure out maybe the temperature at a particular time. So at time equals 0, what was the initial temperature? So that's what we call initial conditions. But we'll do one to figure out what exactly that c value is. So let's do another problem. Okay, so let's say we want to figure out this next problem. So let's say we have dy over dx is equal to x over square root of x squared plus 1 times y. Okay, so what would this be? Okay, so you can either pause the video or you can just do it with me. Okay, so the first thing that you want to do is separate these variables. So let me multiply by dx to both sides. Okay, so I'm going to multiply dx to this side and dx to this side. So this is going to go away. So I'm left with dy by itself is equal to x over the square root of x squared plus 1 times y dx. Okay, now notice I want to be able to separate this out. I need to move this y. So what I'm going to do is I'm going to divide by this y to the other side so that I can get rid of it. So I have 1 over y dy is equal to x over square root of x squared plus 1 dx. Okay, so now I finally moved all my y's and I put all my x's on one side. So usually this will take a little bit of algebra, if you can't quite do it, then maybe think about that. If you can't quite move all the x's and the y's, then probably it's not going to be separable at all. Okay, so now what you want to do, let's go ahead and integrate both sides. Okay, so I'm going to take the integral. The integral of 1 over y is just going to give me the natural log, absolute value of y is equal to. Now this integral, we're going to have to do a little bit more work, okay? So this integral, this looks a lot like a u substitution. Of course, you can use trig sub if you want to, but I think u substitution actually will be the best way to do it. So u is equal to x squared plus 1. So the derivative is going to be equal to 2x dx divided over. So I have 1/2 du is equal to x dx. Okay, so what I'm going to have is just the integral of x dx is just equal to 1/2 du. And then you have divided by the square root of the bottom part, which is going to be u. Okay, so I'm going to have ln of the absolute value of y is equal to, let me bring out the 1/2 integral. This square root can be to the 1/2 power, and when I bring it to the top, it'll be u to the negative 1/2 du. Okay, so this is going to give me the natural log of absolute value of y is equal to 1/2. I'm going to take the antiderivative by adding 1. So you're going to have u to the 1/2 divided by 1/2 du. Oh, no, not du. Oh, plus c. Okay, notice that the 1/2s are going to go away. So I have ln of absolute value of y. The u initially was equal to this x squared plus 1. So you're going to get x squared plus 1 to the power of 1/2 plus c. Okay, and now all we have to do is figure out what this y value is. So if you remember from algebra, in order to get rid of a natural log, you're just going to exponentiate both sides. So that's all you're going to be left with is the absolute value of y is equal to e to the power of x squared plus 1 to the power of 1/2 plus c. Okay, now let me fix this a little bit. What I'm going to do, I'm going to have absolute value of y is equal to e to the x squared plus 1 to the 1/2 times e to the c. So this is just properties of exponentials. You can actually remember that if I have the same base, you can just add them up, which is basically what I have there. Okay. So now what I'm going to do, notice that this thing is just any constant that I can think of. So e to the c is just a constant. If I put it in the calculator, e to the power of 3, that's just going to give me a number. So I'm just going to write it as a. Okay, I'm just going to write a. Okay, so absolute value of y is equal to, I'm going to write that a there, and I have e to the x squared plus 1 to the power of 1/2. Okay, and now finally we have to get rid of this absolute value. So remember that in order to solve absolute value problems, then this absolute value can either be a positive or a negative answer. So y equals positive or negative a e to the x squared plus 1 to the power of 1/2. Okay, now this positive or negative, notice that it's with the a, so that means a can be just another constant. So you can just write it as y is equal to a e x squared plus 1 to the power of 1/2, where a can be anything. A is any number, any real number. Okay, so any positive or negative number, and it can also be 0, of course. Okay, so this one was a little bit more involved. It involved way more algebra, so you have to be very, very comfortable with algebra and knowing how to be able to do basic integration and also be able to do exponentiation with natural logs. Okay, so in the next video, I'm gonna do the same problems, but now to try to figure out where exactly are these constants. So how can I figure out what these constants are? So we just been solving the problem and then saying this is just the right answer. Now in the next video, we're gonna go ahead and solve for these constants.